Imagine a world where particles can exist in two places at once, or spin in opposite directions simultaneously. Welcome to the realm of quantum mechanics. In this domain, the laws of physics as we know them take a back seat and a whole new world of possibilities emerges. Let's start our journey with Max Planck, the man who dared to delve into the world of the ultra-small. He introduced the idea that energy is quantized, that it comes in small discrete units. This was a radical departure from the classical physics of the time, which viewed energy as continuous. His breakthrough laid the cornerstone for the edifice of quantum mechanics. Then came Albert Einstein, who expanded on Planck's work with his explanation of the photoelectric effect. He proposed that light, too, is made up of packets of energy, or quanta. These quanta, which Einstein called photons, challenged the long-held notion of light as a continuous wave, marking a quantum leap in our understanding of the nature of light. Following in their footsteps, Werner Heisenberg and Erwin Schrödinger further developed quantum theory, each in his own unique way. Heisenberg, with his uncertainty principle, showed us that in the quantum world, precision is a luxury. We can't simultaneously know both the position and momentum of a particle with absolute certainty. On the other hand, Schrödinger gave us a wave equation that describes the probabilities of a quantum system's different states. His famous thought experiment, Schrödinger's cat, illustrates the peculiar concept of superposition, where a quantum system can exist in multiple states at once until observed. These groundbreaking discoveries reshaped our understanding of the microscopic world. They unveiled a realm where particles behave like waves, and waves behave like particles. A realm where the familiar laws of physics seem to be turned on their head. Quantum mechanics might sound like science fiction, but it's very real, and it earned these great minds a well-deserved Nobel Prize. From the tiniest particles to the vast cosmos, let's explore another groundbreaking discovery that reshaped our understanding of the universe. Albert Einstein, a name synonymous with genius, brought us the theory of relativity, a revolutionary concept that forever changed our perception of space and time. This theory, a beautiful blend of mathematics and philosophy, proposed that space isn't just an empty stage where events unfold, but rather, it's interconnected with time, forming a four-dimensional space-time continuum. This radical theory suggested that massive objects like stars and galaxies can actually distort this space-time fabric, creating what we perceive as gravity. Imagine a bowling ball on a trampoline. The ball warps the fabric of the trampoline, creating a dip around it. Now, if you roll a marble across the trampoline, it will naturally move towards the bowling ball, not because of a mysterious force, but because of the curvature the bowling ball created. That's a simplified analogy of how gravity works, according to Einstein's relativity. But the universe had another surprise up its sleeve. Enter Edwin Hubble, an astronomer with a keen eye and a namesake space telescope. Hubble's observations of distant galaxies led him to a startling conclusion. The universe was expanding. This meant that galaxies were moving away from each other, like spots on an inflating balloon. This mind-bending discovery, now a cornerstone of modern cosmology, suggested that the universe had a beginning, a moment of creation, now famously known as the Big Bang. Einstein's theory of relativity and Hubble's discovery of an expanding universe have revolutionized our understanding of space, time, and the cosmos itself. They've given us a framework to comprehend phenomena from black holes and neutron stars to cosmic inflation and dark energy. As we gaze at the stars, we owe our understanding of the cosmos to these Nobel laureates whose theories still guide astrophysics today. So we've journeyed through the quantum realm and the cosmos. Now, let's dive into the world of electromagnetism and particle physics. Imagine living in a world without electricity, without any of the modern conveniences we take for granted. Sounds pretty bleak, right? Well, we can thank James Clerk Maxwell for making sure we don't have to. Maxwell was a Scottish scientist who, back in the 19th century, formulated the classical theory of electromagnetic radiation. His equations united the forces of electricity and magnetism into one, showing us they're two sides of the same coin. This groundbreaking work laid the foundation for nearly all of modern physics and led to the technology that powers our world today. But that's not all. Let's fast forward a bit to the 20th century, where we meet Richard Feynman, an American theoretical physicist known for his work in the path integral formulation of quantum mechanics. Feynman was a key player in the development of quantum electrodynamics, the theory that describes how light and matter interact. This work not only won him a Nobel Prize but also gave us a deeper understanding of the natural world. Feynman once said, "Nature uses only the longest threads to weave her patterns, so each small piece of her fabric reveals the organization of the entire tapestry." His work in particle physics helped us see these threads, these fundamental particles that make up everything we see. His diagrams, aptly called Feynman diagrams, are still used today to visualize the behavior of subatomic particles. These brilliant minds, Maxwell and Feynman, took us on a journey deeper into the fabric of the universe, unveiling secrets of electromagnetism and particle physics. Their discoveries have not only shaped the course of scientific thought, but also had profound impacts on our everyday lives. From the electricity that powers our homes to the fundamental particles that make up our world, their work has truly illuminated our understanding. From the electricity that powers our world to the particles that make up everything we see, these Nobel laureates have truly illuminated our understanding. From the quantum realm to the farthest corners of the universe, these Nobel laureates have made discoveries that have profoundly shaped our world. We've journeyed through the mind-boggling world of quantum mechanics, where particles can exist in two places at once, and peeked into the expanding universe, where galaxies drift apart faster than the speed of light. We've delved into the fascinating realm of electromagnetism and particle physics, where invisible forces hold our universe together, and marveled at the technological breakthroughs born from these insights, from lasers to semiconductors, that power our modern world. Each of these groundbreaking works underscores the transformative power of science and the indomitable spirit of human curiosity. They've not only expanded our understanding of the cosmos, but also enriched our daily lives in countless ways. As we continue to explore the mysteries of our universe, who knows what future Nobel Prize-winning discoveries await us? Until then, keep exploring, keep learning, and keep marveling at the wonders of our universe.